Good morning, my dear students. Today I am going to discuss the next topic, coordination compounds. I am Dr.R.G, Professor of Chemistry, who is taking class for you. So, under the coordination compounds, before entering, let me discuss about the types of salt. Because coordination complex or compounds is one of the type of salt. So, let me give some introduction regarding the types of salts. I can classify the salts into three types mainly. One, simple salts, example sodium chloride. Double salts, example more salt, that is ferrous sulfate, ammonium sulfate, dot 6H2O. Normally we are using as a primary standard in the volumetric, especially in potassium permanganate titrations. And third, complex salt, here I am giving example potassium ferrocyanide, K3 within bracket FeCN6. So these are the three important types of salts. Let me go in detail of one by one. First, let me come for the simple salts. Kindly follow. Coming for the simple salts, I can classify further into three types. One is neutral salts, acidic salts, and three basic salts. Let me concentrate first on neutral salts. How a salt is formed? Yes, normally a salt is formed by complete neutralization of 1 mole of a strong base with 1 mole of a strong acid to produce 1 mole of a salt plus water. Kindly follow. This is the specific example. Sodium hydroxide 1 mole reacts with 1 mole of HCl gives sodium chloride and water. So this is a strong electrolyte, this is a strong electrolyte, this is also a strong electrolyte, but water is a weak electrolyte. So this salt we are calling it as a neutral because 1 mole is completely neutralized without any external agency. If you mix sodium hydroxide and HCl, it automatically converted into sodium chloride water. Kindly follow. This is a salt of, let me call it as, sodium chloride is a salt of strong acid versus strong base. Please follow. Strong acid, sodium hydroxide, strong base HCl. And the second example, neutral salt, that is sodium acetate. Example, it is a salt of strong, that is weak acid versus strong base. Weak acid means acetic acid is weak and sodium hydroxide is a strong base. Then ammonium chloride is a salt of weak base. Kindly follow. Weak base versus strong acid. Kindly follow. Weak base versus strong acid. And lastly, the ammonium acetate, weak base versus weak acid. So ammonium chloride reacts due to ammonium hydroxide and HCl. Ammonium acetate due to weak acid, acetic acid, weak base, ammonium hydroxide. So that's why these are four salts. Sodium chloride is a neutral salt, sodium acetate is a neutral salt, ammonium chloride is a neutral salt, ammonium acetate is also a neutral salt. What is acidic salts? So when you go for acid, there are monobasic acid, dibasic acid, tribasic acid, etc. Example, suppose HCl is a monobasic acid. sulfuric acid is a dibasic acid. Phosphoric acid is a tribasic acid. Kindly follow. So, suppose if you take sulfuric acid or phosphoric acid and if you neutralize, not completely, please follow, incompletely neutralized, so the replaceable hydrogen atom still will be present in that. So these type of salts we are calling it as acidic salt. So acidic salts are formed to incomplete neutralization of acid by base. Please follow. Sodium bicarbonate. So it is due to the carbonic acid is an acid, sodium hydroxide is a base. So weak acid, strong base. Kindly follow. Incomplete neutralization, sodium bicarbonate. Same way, sodium bisulfite. Kindly follow. Another example, sodium bisulfate. Then, sodium hydrogen oxalate, sodium dihydrogen phosphate. These examples are acidic salts. Then, what are basic salts? As I already informed, now there are metal having the salt having the corresponding base having acidic salt. I will call it as monoacidic, diacidic, triacidic, like that. Say for example, if you come for the second group metals like magnesium, calcium, that is beryllium, magnesium, calcium, strontium, barium, radium. These are all second group, valency 2. So when they form, for example, automatically they will have calcium hydroxide, for example, 2OH. This is called the diacidic correspondingly base, acidic base. 2OH groups are there. So basic salt. So when the base is neutralized incompletely by an acid, so we are having one OH or two OH may be present inside. This type of salt will act as basic salt. Suppose you take aluminum hydroxide, it is the triacidic base. Kindly follow. So here let me take first one. Lead, the OH twice, it is neutralized by 1 mole of HCl. See, OH is neutralized by HCl. So this is the salt form, this is basic. Same in the case of aluminum hydroxide, incomplete neutralization gives AlOH2Cl. Same way here, tin OH, the corresponding NO3 twice. So we are getting the examples of basic salts. So simple salts we can classify into 3 types: neutral salt, acidic salt, and basic salt. Question can be asked: one among the following is neutral, one among the following is acidic salt, one among the following is a basic salt, can be asked. Now coming for double salt. What are double salts? So crystalline substances which are behaving as a single salt in solid state, but when placed in solvent, suitable solvent, specifically water, it will behave as a single salt. This will call it as double salt. Example, more salt, I have already informed you, ferrous sulfate, ammonium sulfate, 6H2O. So it is acting as a single salt in solid state, but in liquid, when you dissolve, it will act as a ferrous sulfate as well as the ammonium sulfate separately. The second example, kernelite, is an example of potassium chloride, magnesium chloride, 6H2O. So in solid state, it's acting as a double salt. When liquid state, it is acting as a monosalt. That is potassium chloride and magnesium chloride separately, it will act. The last one, potash alum. Potassium sulfate, aluminum sulfate, 24H2O. Here, acting as a double salt in solid state, in liquid it is becoming a single potassium sulfate, aluminum sulfate, 24, that is H2O, it go in solution. Let me come for the complex salts. Some more information I want to give. Examples, potassium ferrocyanide. Please follow, I am giving common name. IUPAC name I will come later. Potassium ferrocyanide. What is the difference here? Ferri, I am using 3. Ferro, I am using 4. Kindly follow. Ferri, 3. Kindly remember this way. K3 FeCN6, K4 FeCN6. Kindly follow. Examples. Now, these complex salts I can classify into number of types. That is 4 types I can classify. One is simple neutral complex. Example, nickel tetracarbonate is a neutral. Everything within square bracket. We will come later. That is called nothing but sphere. We will call it as anionic complex. Kindly follow. When we are writing any, for example, potassium chloride, potassium is plus, Cl is minus. Same way in this complex, if you ionize, you will get 3 potassium plus FeCN6 3 minus. So, it is acting as a 4 species, 4 ion, 3 potassium ion, 1 FeCN minus CN6, 3 minus ion. That means it is an anionic complex. So, anion is complex. Kindly follow. That's why anionic complex. The same way, this is cationic complex. Tetraamine copper sulfate. Cation is a complex, anion is sulfate. Here, both cases, cation and anionic complex. Both cases, that is complex. Anion is also complex, cation is also complex. Normally, left side will be cation, right side will be anion. Kindly follow. Now, the next I am going to discuss the terminology used in coordination chemistry. So, when you are studying coordination compounds, whatever the terminology we are using, so that you can easily understand when you go inside the theory, isomerism, with the IUPAC name and application, etc. First one, central metal ion. Number 2, ligand. Number 3, oxidation state of central metal ion, atom. Coordination sphere. Coordination number. Charge of the complex ion. So, these are the terminology we are going to use. Let me explain one by one. What is meant by central metal atom or ion? The central metal atom or ion is one where fixed number of ions or atoms or groups are bound in a definite geometrical arrangement around it. Let me repeat again. Central metal atom or ion is one where the fixed number of ions or atoms or groups are bound in a definite geometrical arrangement. Kindly follow. The examples, a number of 3 examples I am giving. So this is first one, potassium ferrocyanide, central metal ion is iron. Here, the hexaamine cobalt 3 chloride. So here cobalt is the central metal ion. Then tetraamine copper 2 sulfate. This is copper is the central metal ion. So how to identify central metal ion? Very easy. So find out the square. That is coordination sphere means indicated by a square bracket. And inside whatever metal is there, that metal is central metal ion. Please follow. It is present in the complex coordination sphere. Easy way to understand. Now, coming for ligands, very, very important. The ions or molecules bound to the central atom or ion in the coordination sphere are called ligands. Kindly follow. Normally, in the inorganic compound, we are calling it as radicals. Here, we are using the terms ligands, which are Lewis bases. According to modern theory, Lewis bases means which donate lone pair of electron. So the ions or molecules bound to the central atom or ion in the coordination sphere are called ligands, which are Lewis bases. Example, let me give here, kindly follow. Neutral ligands. There are neutral ligands. So three types I can classify: neutral, negative, and positive. So neutral and negative is common, whereas positive is very, very rare. Kindly follow. Because in all our books you are going to see only positive and the negative and neutral ligands, but positive the ligand we are not studying in detail. Anyhow, I am giving example. Neutral, kindly follow. Ligand is ammonia. In this complex, tetramine copper 2 sulfate, ammonia is neutral. Same way here, hexa aqua cobalt 3 chloride, the water H2O is a neutral ligand. See what happened ligand? See, when you write the structure of ammonia, so there is a lone pair. So this lone pair it is donating, so it is acting as a base. Ligand acting as a base. Same way water we know the sample having two lone pair, so it is also acting as a ligand, neutral ligand. Kindly follow. Coming for negative, we have a number of negative ligands. So specifically, let me indicate one or two. Here, the central is Cn minus is a ligand, negative. F minus, it is ligand, negative ligand. Coming for positive, you know the neutral molecule that you will be studying here in organic chemistry when you come, hydrazine. This is called hydrazine. NH2, NH2. But when you treat with protons, this will be converted into this ion. This is called hydrazonium ion. So this is acting as, because this is a positive species, but this lone pair present in the nitrogen will donate electron. So this is a positive ligand. Please follow. Very, very important. Here I want to give one information. Hydrogen, the compound, which will not answer for nitrogen test in the Liebig, that is in the Lethini test, sodium fusion extract. The answer, because in order to answer for the nitrogen test, it has to convert it into sodium cyanide. But this hydrogen is not containing carbon, so this will not answer. This is most important. Often this question is asked. Kindly follow. Next, oxidation state of central metal ion. Oxidation state of central metal ion. We know what is oxidation state. Valency we know, oxidation state you know. Valency is neutral, oxidation is plus or minus. The oxidation state or number of a central metal ion in a complex is defined as the charge it would carry if all the ligands are removed along with the electron pairs that are shared with the central atom. Kindly follow. The oxidation number is represented by Roman numeral in parenthesis. Roman numeral in parenthesis. For example, 2 or 1. So it will be given in parenthesis. Kindly follow. So, in the case of tetramine copper 2 sulfate, sulfate 2 minus, ammonia neutral. So therefore copper is, we will write here copper 2. We are writing. Kindly follow. So this is the Roman numeral. The same way hexamine cobalt 3 chloride, chloride 3 chloride 3 minus. So ammonia neutral. So oxidation state of cobalt is 3. So we can write cobalt within bracket 3, Roman letter 3. Kindly follow. So very easily you can identify by removing these ligands and by comparing with the sulfate, the anion, we can identify the charge of the cation. Because total charge should be equal. in order to form neutral complex. The next, coordination sphere. The central atom or ion and the ligand attached to it are enclosed in a square bracket, and collectively termed as coordination sphere. Can you follow? The central atom or ion and the ligand attached to it are enclosed in a square bracket and collectively termed as coordination sphere. See, for example, here, in this case, tetraamine copper 2 sulfate. So this is the coordination sphere. Can you follow? CuNH3 4 times. Coordination sphere. So outside you will write 2 plus because sulfate is the ion. So this is the coordination sphere. Same way here, coordination sphere indicated by square bracket. So here we will write CONH3 6 times 3 plus. This is the coordination sphere. Kindly follow. Okay, next. Coordination number. Please follow. Sphere, now number. The total number of ligands, please follow, that are attached to central atom or ion is called coordination number. The total number of ligands that are attached to central metal ion or atom is called coordination number. Kindly follow the example I have given here. The same example. Tetraamine copper 2 sulfate. So how many ligands inside the square of the coordination sphere? Central metal atom copper. How many ammonia? 4. So coordination number is, here it is 4. What about here in this hexamine cobalt 3 chloride? Coordination number is 6. So depending upon the coordination number, shape will vary. That we will discuss under the theory of coordination compound. Kindly follow. Then charge of the complex ion. This is the very, very important. When I was writing the coordination sphere, I was indicating the charge of the complex outside, that is charge of the complex. The total number of charges that are present outside the coordination sphere is called charge of the complex. The total number of charges that are present outside the coordination sphere is called charge of the complex. Kindly follow. Let me come back. Example, kindly follow. Tetraamine copper sulfate. I will write the sphere in the form of within bracket CuNH3 4 2 plus. Sulfate is 2 minus 2 plus. Same way, hexamine cobalt 3 chloride. So this is the ion, charge of the complex ion is 3 plus. Potassium Ferrocyanide. So F is minus C6. Outside 3 minus. Here why 3 minus? Cn is minus, 6 minus. So 6 minus, actually there are 3 potassium outside neutralized. So remaining is 3 minus we are writing. So charge of the complex here it is 3 minus. Please follow. Now I am coming for the next most important part of coordination compound. Naming of coordination compound by IUPAC rules. So, IUPAC rules we have discussed in the case of basic concept of chemistry, organic chemistry, and we have classified into 2 types, type 1 without any functional group, type 2 with 1 functional group, type 3 more than 1 functional groups. Here it is entirely different for inorganic compounds. Kindly follow. Number 1, the first rule number 1. While naming a complex, please follow, the name of the cation is given first, written first, and the anion is second. This is the general rule. Say for example, potassium chloride, how we are writing? Potassium chloride. Potassium chloride we are writing. Kindly follow here, I want important information based on my experience I want to give. If you go to Spain, they are using a different way. That is, they are calling it as chlorido potato. So they are mentioning a different way, anion first and cation later. But as per IUPAC rules, while naming a complex, the name of the cation first and then anion second. This is the universal IUPAC rule. No matter whether the cation or anion is the complex species. You need not worry about the complex. It's a cationic complex or anionic complex. You need not worry. But always name first cation and then anion. Example, now I am taking one is, kindly follow, this is the IUPAC name. Potassium hexacyanoferrate 3. Kindly follow. So how I am using the term, kindly follow. The first is potassium I am using. And if I write the coordination sphere, kindly follow. So the charge outside this is here minus, so 6 minus will be there. 3 is already neutralized, so 3 minus I am writing. Kindly follow now. Actually this is happening now. So that means this 3 minus, here kindly follow, the ferrate I am using them because it is present in the negative anionic complex. So whenever metal is in the negative form, we are using AT. So ferrate. So potassium hexacyanoferrate to indicate the anion, and 3, that is the oxidation state. Kindly follow. Please follow. Now, rule number 2, while naming a neutral or cationic complex, I told you cation first, anion second. That is the general rule. But while naming a neutral or cationic complex, the ligands that are coordinated to the central metal atom or ion should be named first. See here, I told you first cation first, anion, right? But if there is any ligand present there in the cation, kindly follow, you have to name the ligand first, then only cation. Kindly follow. There should be, that is, while naming a neutral or cationic complex, kindly follow neutral as well as cationic complex. The ligands that are coordinated to the central metal atom or ion should be named first in the alphabetical order, irrespective of negative or neutral or positive, and then the metal ion. Kindly follow example. Tetraamine copper 2 sulfate. Kindly follow tetraamine. I am using carefully. In organic chemistry, I will use amine AMINE, but here using double M I am using. Please see the difference. In inorganic chemistry coordination, I am using tetraamine copper 2 oxidation state sulfate. Kindly follow. So tetraamine, it is a ligand. The next metal cation, oxidation state, Roman numeral sulfate. Please follow. This is the rule 2. Please understand this. But there will be a single letter, single word. No hyphen or nothing is indicated there. It's a single line. Kindly follow. Number 3. Rule number 3. While naming the ligands, now only problem started. While naming the ligands, the negative ligands having names ending in O. Ending with O. The negative ligands always ending with O. But for neutral ligands, the names are not systematic. It is given as in the book. But the name of the free molecule is used as such. Kindly follow. Only negative ion is ending with O. Kindly follow. Example. Now, neutral ligands example I am giving. Water. When it is present, we will use the two terms, aqua or aquo. Alphabetically, A comes. So, when you are arranging, priority should be given for aqua. Then ammonia neutral will give it as amine, AM. So when the water and ammonia comes, ammonia takes priority because second letter Q, this is M, so amine takes priority. CO, carbonyl, NO, nitrosyl. So this is the specific example for neutral ligand. Coming for negative ligands, you should be very, very careful because normally negative ligands are more in the coordination compounds. So let me take now, here is a table, negative ligand. F minus, I can say fluoro or let us fluorido. Both are correct, but generally we will use fluorido. But nothing, the fluoro we are using normally. So instead of that, removing that O, we are using IDO, fluorido. Same way, Cl minus chloro, chlorido. Br minus bromo or bromido. I minus iodo or iodido. Cn minus cyano. SCl minus thiocyano. OH minus hydroxo. Kindly for all are ending with O, please follow. NH2 minus amido. Please follow. NH2 minus, not amine. It is amido. Then NO2 minus nitro. ONO minus nitrito. NITRITO, nitrito. Then NO3 2 minus, NO3 2 minus nitrato. The normally will what will use, nitrate will use. So what I am doing now, simply I am removing E, I am adding O, nitrato. Please follow. Ordinary way nitrate. The same way sulfate, sulfato. Carbonate, carbonato. Oxalate, oxalato. Very, very easy to convert. Drop E, add O. Please follow. This is the negative ligand. Kindly follow. Rule number 4. If more than one ligands of same type is present, so for example H2O2 type, NH3 2 times like that, then a prefix such as the di, tri, tetra, etc. is used to indicate the number of ligand in a complex. If more than one ligand of same type is present, then a prefix such as di, tri, tetra, etc. is used to indicate the number of ligand in a complex. Example, tetraamine copper sulfate. Please follow, I am writing in a single line. Tetraamine copper 2 sulfate. So, what I am using, there are 4 ammonia ligands, so I am using tetra. Kindly follow. So, di, tri, tetra, penta, hexa, like that we are using. Kindly follow. Rule number 5. While naming a neutral complex, please follow a neutral complex, nickel tetracarbonyl. The name of the ligand or ligand should be named first, followed by central metal atom or ion with Roman numeral in parenthesis giving its oxidation number. Kindly follow. So neutral means the oxidation state should be written as 0 in the numeral. Kindly follow. 0, that is used for the oxidation state of 0, and 1 for oxidation state of 1, 2 for oxidation state of 2. Example, kindly follow. So in this case I am using 2 amine and ammonia, 2 chlorine. So what is a neutral? Because why I am calling it a neutral? Within the square bracket, outside there is nothing there. One important information you have just know that When you dissolve these coordination compounds, whatever species present inside the coordination pair will not undergo ionization. Only outside this coordination pair, the ion will undergo ionization. This is important point you must know. So this I will call it as diamine dichloroplatinum 2. Please follow. It's a neutral, so I am not using platinate. Only negative ending in ion will use ferrate, cuprate, like that, plumbate. So diamine dichloroplatinum 2. So in this case, there is NO2 3 times, NH3 3 times. So 6 ligon. Cobalt is the center metal atom. It's a neutral again. So alphabetically, the NH3 triamine, kindly follow, trinitro, cobalt 3. Again neutral. Please follow. Now, rule number 6. While naming a cationic complex, the name of the ligand should be mentioned first, followed by central metal atom or ion with a Roman numeral in parenthesis giving its oxidation number, and then the name of the anion. So, in the case of cationic complex, example, tetraamine copper sulfate, so ammonia 4 times. So how many name? Tetra. Name is amine, tetraamine. So copper, we have to, what about the oxidation state? Find out the anion, SO4 2 minus. So it should be 2 plus. So 2 is the oxidation state. So sulfate. Please follow. Tetraamine copper 2 sulfate. The same way, if I take this complex, outside Cl3, 3 minus, ammonia neutral. So cobalt should be 3 plus. So hexaamine cobalt 3 chloride. Please follow. This is the way we have to. So first the ligand, then metal with the oxidation state in Roman numeral, then our cation. Please follow. 7th rule. While naming an anionic complex, so listen, the rule for cation and neutral, they are same. Whereas coming for the anion, it is different. While naming an anionic complex, the name of the metal cation should be mentioned first. And then the name of the ligands of the anionic complex. And finally, with the name of the central metal atom ending with ATE. Because it is coming in the anionic part, so it is ending with ATE, followed by Roman numeral in parenthesis, giving its oxidation state. Kindly follow. So, let me give example here. So, this is normally I am using potassium hexacyanoferrate 3. Common name potassium ferrocyanide, I told you. 3 ferricyanide, 4 ferrocyanide. So here I am using first potassium. Kindly follow the metal atom because cation first. Then in the anion I am naming the ligand is how many ligand? 6. So hexacyano. Now ion I am writing in the form of ferrate. 80. 3 is oxidation state. Kindly follow. So you must know in the anionic complex, whatever metal is coming, that corresponding name you have to memorize. Ferrate, plumbate, cobaltate. Like that, you have to memorize from the book. The next. This is potassium ferrocyanide common name. But I will give the IUPAC potassium hexacyanoferrate 2. Why I am calling it 2 here? Because if I write FeCN6, then the outside I am writing only 2 plus. 2 plus means the corresponding 6 minus should be there. So 6 minus means actually 6, the outside there are 4. So it is neutralized potash plus. Only 2 remaining, that is 2 is due to the the 2 minus here. So this ion is 2 plus. Kindly follow. Then only the total number of positive and negative will be equal. So potassium 4 plus, Fe 2 plus, so 6 plus, and cyanide 6 minus, so neutral. Kindly follow. Potassium hexacyanoferrate 2. Now, it is rule number 8. If the ligands are complex, use of prefixes such as bis, tris, etc. should be followed by the name of the coordinated group set off by parenthesis preferred to that of old designation di, tri, etc. Instead of di, tri, etc., if the ligand is a complex ligand, we have to use bis, tris, etc. Example, kindly follow. This is the example. What is En? En is nothing but, kindly I will write this way. Ethylene diamine. Kindly follow. This is the ligand. So this is the ligand. It is present inside. Kindly follow. This is ethylene diamine. Kindly follow. This is the En, twice it is given clearly. It is present inside. Kindly follow. So this is a ligand having, so this is having a lone pair, this is also having lone pair, so it is donating electron to the central metal ion cobalt. So if such a complex is coming, we have to use bis or tris we have to use. So now let me name, kindly follow me. The first cation first we have to name. Among the, if it is a cation, so we have to use first give priority for this ligands. In this case, ligands, so amine, this is amine number 1, then chloro number 2, then nitrate number 3, order of priority in alphabetical order. So what I am using now? Chloro, kindly follow. C, I am giving priority. Chloro, only 1. Then bis, I am using ethane 1,2 diamine. So this is the using the name. Kindly follow. 1,2 ethane 1,2 diamine. I am using. Kindly follow. Nitro next, cobalt 3 chloride. Please follow. This is the cationic complex. Very, very careful, you must know. The another one, 9th rule, ligands which link two centers of coordination, that is pi-dentate ligand, two centers of coordination are usually separated from the rest of the complex by hyphen and are denoted by Greek letter mu. This is a special case. Kindly follow. This is represented before the name of each kind of bridging group. Let me repeat again. Ligands which link two centers of coordination by dentate ligands are usually separated from the rest of the complex by a hyphen and are denoted by the Greek letter mu. This is represented before the name of each kind of bridging group. Example, just see here. This is the example. Just see both sides there is cobalt and here 4 amine, here also 4 amine. The NO2 is linked by the 2CO. Outside, this is within square bracket. Everything, the coordination sphere is here. Kindly follow. So, NO3 is outside. 4. That means 4 minus is outside. So, inside is 4 plus. Kindly follow. Now, kindly follow in this case, how many amino group? 4 plus 4 amino groups are there. 4 plus 4 amino groups. So, octa-amine. Sorry, there is no space. Kindly write together. Octa-amine. Now, in order to indicate the nitro group, bridge nitro group, hyphen mu hyphen dinitro dicobalt, kindly follow, 3 nitrate, kindly follow, 3 nitrate. Why I am calling it a 3 nitrate? Because 2 cobalt atom, total number of negative 4 plus 2 6, so 6 divided by 2 3, so it is 3 nitrate. Please follow. Octaamine mu dinitro cobalt, this again space is there, should not be there, 3 nitrate, kindly follow. Okay. I hope I have come to the conclusion, my dear students. So you have enjoyed the what are coordination compounds, example, types, and how to name IUPAC. This is the most important. Normally, one question will be asked under this IUPAC name. My dear students who are viewing the YouTube for the first time, my channel, Neat Chemistry by Dr.R.G. So I request you kindly click like and subscribe, click subscribe button to motivate me. And also share with your friends so they can also get benefited. So I have started this channel in order to help poor students of India. Poor students of India I have started. So if they follow systematically the YouTube of my channels, so I am going to discuss after finishing the chapter, I will be discussing also question papers of previous year question papers of 20 years of IIT, the AIPMT, AIMS, AFMC, MSET, Andhra, Karnataka, Delhi question paper I will discuss. From each year twice I will discuss. So that will be very, very useful to you. So you can shine not only in class, your school, but also in NEET entrance examination will be conducted by Government of India. So you will get 180 out of 180, definitely you can get. So this is what you can say, it's a gold opportunity for poor students. Kindly utilize and become doctors. My always blessings are for you. Now, I am going to give one information for the student who are studying +1 and +2 and +2 completed students who are waiting to write NEET entrance examination will be conducted by Government of India for this academic year. For you, I want to give three important informations or features of our site Vetri Daughters and our center Vetri Coaching Center. We are running a Vetri Coaching Center in Pondicherry for the last 21 years, since 1999. We have a lot of achievements, even from the beginning. We have one or two I will indicate. It is my duty. Every year, 10 to 20 students from Vetri Coaching Center are joining to Jipar Medical College. And 150 to 200 students are joining other medical colleges in merit-wise. And a few students are joining IIT and hundreds of students are joining other engineering colleges present in Pondicherry and outside. Please follow. And the most important achievement for us, in 2003, R. Srinivasa Raghavan from Patrick School studied in our Vetri Coaching Center from 9th, and he came All India first rank. This is our achievement in 2003 itself. At that time, NEET Common Entrance Examination was not there. With this introduction, let me give information about Vetri Daughters. What is the important features of Vetri Daughters? Vetri Daughters has three important features. Number one, it has 200 video lesson, 200 unit test. Please follow. 200 video lesson, 200 unit test. All video lessons are recorded or taken by professor with a doctorate degree and 20 to 30 years of experience in coaching IIT and medical students. Also, they are the teaching BSc, MSc, MPhil and PhD students. So highly qualified as well as experienced in coaching. So more suitable, who can give very clear idea without any doubt. And in the video, the lesson, when you are viewing the video lesson, kindly follow. The video will run, the professor will talk, and he will stand in front of the board, he will write everything you can see. Suppose you want to note anything, just touch at the center, the video will stop. You can take your notes, formula, definition, anything new to you, information, note it, and then again touch, it will run. Please follow. This facility is available, like YouTube. Please follow. Okay, then coming for the 200 unit tests, so approximately 50 tests for each subject. Dear students, all the questions asked in the unit tests are framed from 20 years of previous question papers of IIT, AIMS, AFMC, AIPMT, MSET Andhra, Delhi, Karnataka, Kerala, Tamil Nadu, Pondicherry. Only these question papers are there. No question are written by us. Please follow. What is the advantage of the giving question papers? So students will be trained in such a way that when they go for NEET entrance examination, they will not find difference between when they are writing entrance test in NEET as well as the Vetida test and the NEET, they will not find any difference. Nothing but same. Experience will be same. So we have observed for the last 6 years, nearly 75 to 80 questions of same questions are repeated. Same question without changing even letter, repeated. We have observed for the last 6 years. That means Vetida test will give you 320 marks. And if you are a good student, because of your capacity, you can take 300 plus. So easily you will score 600 to 700. You will become all India rank. Then you can join JIPMER, AIMS or Vellore or any medical college you want, you can join. Please follow. This is the one important feature of Vetida test. The second important feature I want to give regarding the test. So while you are writing the unit test, kindly follow. If you have to enter, after registration, you go enter. There are lessons, so many menus are there. You have to go for the test menu, click test, and there is an attempt, and go for unit. Here for now, what unit? Coordination compound. Coordination compounds, you have to go. There are 2 tests will be given. Test 1, test 2, as usual, I told you, 45 questions will be there. So there is a menu called attempt. If you click attempt in the coordination unit, immediately a window will open. In the window, so kindly follow, in the window, it will be asked, it will give information. This unit, coordination unit, has 45 questions. Each question carries 4 marks. If you answer correctly, for correct answer 4 marks awarded, for wrong answer -1 subtracted. Are you ready? It will ask. Then if you are ready, take a rough notebook ready with the pen and then click. When you click, automatically a clock will run from 45, it will come down backwards. 48.59, 48 like that, it go, that is 45 means 44.59, 44.58 like that, it will go down. So now let us assume. So when you click attempt, immediately question number 1 will open. Kindly follow. You can see option A, B, C, D, and there are 3 other options are there, below which again 1 to 45 question number will be there in yellow color. Please follow. This is the importance. So when you click attempt, immediately window open, you can see the question number 1. You can read the question and view the option A, option B, option C, option D. Below that, there are 3, the menu, the center is complete. This is you have to touch only after finishing the test. Right is that is the next, left is reverse. So the right, if you click, you go for next question. Left, reverse, you click, you go for reverse question, back. And also another provision is given by us, that is below there is 1 to 45 number, yellow color. This provision is not available in any other online coaching. Please compare and verify. Please compare and verify. So we are not telling any lie. So what will happen now? Suppose if you observe that if you answer question A is correct, that is option A is correct, put a tick mark, click. If you click A, automatically question number 1, which was in yellow color, it is becoming now green color. It becoming yellow to green. Number 2 will become blue, all other questions will be yellow. So if you are attending one by one, what you can say, at any stage you can see, you are able to see what are the questions attended, what are the questions not attended, you can see yourself. This is the advantage we are giving, Dr.R.G is giving to you. If you go for other online, this facility is not there. Whether you attended or not, you cannot see. Please follow. This is the most important information. After completing all, then come for complete. Press complete. Immediately a window will open. In the window, kindly follow. What is happening now? There will be question 1. Option A, option B, option C, option D. Again, correct answer also will be given. Correct answer. Option A will be in blue color. In blue color. Correct answer will be in yellow color. And below that, there is a video solution. Kindly follow. So this is the window you have. If you press, kindly follow, review menu. After getting marks, because after clicking your complete, immediately you can see your marks. Say for example, it will calculate the marks and give automatically, let us say you are getting 160 out of 180. You can see the marks. After seeing the marks, you are losing 20 marks. So you want to verify where you have done mistake. So you have to verify your answer is correct or not, in which case you have done mistake. There is a menu called review. This feature again is not available in any other online coaching. If you press review, this window will open. So A, your answer blue color, and the correct answer will be yellow color. Below that, there is a video solution. So if blue and yellow is same, your answer is correct. Blue and yellow are different, your answer is wrong. We can easily verify. And if you want to know the answer, please click the video solution. This is the another important feature which is not available in any other online coaching in India. What is that video solution? Kindly follow. So, a professor having doctorate degree with 20 to 30 years of coaching experience will handle classes taking 10 to 15 minutes. You can view him and board and he, and just like a classroom atmosphere, you can observe. Classroom atmosphere, you can observe. He will read question, he will read the option, then he will start explaining what topic or what subtopic it is asked. What is the basic definition? What is the basic principle you must know? What are the chart method? Everything he will explain. And if it is necessary, diagram, tabular column, everything he will provide to you. And finally, how to arrive the answer or how to arrive the correct answer, he will explain. So this facility is not available in other online coaching. Please follow. That's why we are superior than other online coaching center. Please follow. The next most important feature, our Dr.R.G online coaching is a very, very low cost. It is applicable, offered for poor people. Even poor students coming from poor family, they can join with us because only 10,000 rupees per year we are collecting. Per year we are collecting. So how to pay this 10,000 rupees? You have to pay 10,000 rupees in the name of Santi. Indian Bank account number 71271-9471. Account number, IFC code IDIB000P134. And any query or any informations, You contact myself, Dr.R.G 98941764225. This is my WhatsApp number also. Kindly follow. So I hope I come to the conclusion. Thank you very much for kind cooperation. See you again in my next chapter. Bye bye.